Welcome back to CIA Declassified. Today we are ascending into the 1960s and 70s, the high stakes era of the space race. Below us, the world is divided by the Iron Curtain, but from 100 miles up, there are no borders, only targets. After the U-2 was shot down in 1960, the agency realized that the sky was no longer high enough. To see into the heart of the Soviet Union, they needed to go into orbit. We are exploring the dawn of the National Reconnaissance Office, a time when engineers were tasked with the impossible. Build a camera the size of a bus that could survive the G-forces of a Titan rocket and still capture the fine details of a secret bunker through miles of atmosphere. This was a time of secret launch pads at Vandenberg Air Force Base and the birth of the most complex mechanical system ever launched into space. They needed to map every missile silo, every submarine pen, and every bomber base with surgical precision. This was the ultimate vantage point of the Cold War. This was HEXAGON, also known as the KH-9. How did this massive eye in the sky get its name? The designation hexagon was a cryptonym selected by the National Reconnaissance Office and the agency, while the KH in its technical designation, KH-9, stood for keyhole, a naming convention for satellite reconnaissance systems. The name hexagon was chosen to reflect the multifaceted nature of the project. It represented the 6 major subsystems required to make the satellite function: the spacecraft, the panoramic cameras, the mapping camera, the film supply, the recovery vehicles, and the stellar index camera. It was a name that honored the geometric complexity of a machine that had to function perfectly in the vacuum of space. Hexagon wasn't just a satellite, it was a school bus-sized darkroom orbiting the Earth. Hexagon was 60 feet long and weighed 30,000 pounds, making it the largest and most capable film return satellite ever operated by the United States. A quote from a declassified 1971 program review: "The KH-9 provides a search and surveillance capability that is fundamentally essential to the verification of arms control treaties." End quote. Records show that Hexagon carried 60 miles of ultra-thin, high-resolution film, which moved through the cameras at speeds of 200 inches per second. Documentation confirms that the satellite's panoramic cameras, designed by the Perkin-Elmer Corporation, could resolve objects on the ground as small as 2 feet from an altitude of 100 miles. The system utilized 4 re-entry capsules known as SRVSs, which would eject from the satellite and parachute into the atmosphere to be caught mid-air by modified C-130 aircraft. A quote from President Gerald Ford: "Our national security depends on the quality of the intelligence we gather from the high ground of space." End quote. Hexagon mapped the entire landmass of the Earth between 1971 and 1986, covering millions of square miles in a single mission. Logs indicate that the satellite used stellar index cameras to take photos of the stars simultaneously with the ground, allowing for sub-meter geographic accuracy. Technical files revealed that the agency developed a specialized Teflon-coated film transport system to prevent static electricity from ruining the images in the dry vacuum of space. Records prove that the KH-9 discovered the first Soviet Delta-class ballistic missile submarines by spotting their unique hole shapes at the Severodvinsk. I butchered it. Severodvinsk. It's a Russian shipyard, everybody. The agency operated a secret film processing facility in Rochester, New York, known as Hawkeye, where thousands of miles of hexagon film were developed in total darkness. Documentation confirms that the satellite carried a mapping camera subsystem that produced the topographical maps used by the U.S. military for over 2 decades. Memos reveal that the HEXAGON program cost more than the Manhattan Project when adjusted for inflation, highlighting its critical importance. The system utilized a twister mechanism to rotate the entire camera assembly to compensate for the Earth's rotation during long exposures. Records show that the agency used atmospheric scattering models to determine the best time of day to photograph specific Soviet cities to avoid smog and cloud cover. A quote from a declassified memorandum: "HEXAGON was the swan song of film-based reconnaissance, a mechanical masterpiece before the digital dawn." End quote. The program completed 19 successful missions, with only the 20th and final launch ending in a catastrophic explosion on the pad in 1986. Documentation reveals that the agency recovered a film capsule from the bottom of the Pacific Ocean after a parachute failure using a specialized deep-sea submersible. Technical files confirm the use of gas-bearing sensors to keep the cameras perfectly stable while moving at 17,000 miles per hour. Records prove that HEXAGON monitored the building of the Baikonur Cosmodrome, tracking every Soviet rocket launch. Baikonur. Baikonur. I think that's it. The Cosmodrome. Tracking every Soviet rocket launch. Internal reports describe the development of ultra-lightweight mirrors that could withstand the intense vibrations of a rocket launch without cracking. The film used was a special 6.6 micron ultra-thin polyester base, allowing for much longer rolls to be carried without increasing the satellite's weight. The cameras used a folded optical path with a 60-inch focal length, a marvel of miniaturization for the time. The agency utilized a fleet of catch planes based at Hickam Air Force Base in Hawaii to retrieve the descending canisters. During the mission known as KH-9 Mission 1205, the satellite stayed in orbit for 141 days, a record for the era. A quote from a NRO engineer: "We were throwing a football from Los Angeles and catching it in a bucket over the Pacific, only the football was full of the nation's most precious secrets." End quote. The satellite used a lifeboat system, a small secondary thruster, to prevent the massive craft from deorbiting prematurely. Early panoramic camera assembly was capable of scanning 120 degrees across the track of the satellite's flight. Records indicate that the NRO used dummy canisters during training exercises to perfect the mid-air recovery technique. The program's existence was so secret that its declassification only occurred in 2011, 25 years after the final mission. An internal memo from 1974 shows the CIA considered using HEXAGON to track illegal fishing fleets before deciding it was a waste of strategic assets. The optics were so sensitive that they had to be kept in a temperature-controlled environment within 1 degree of variance to prevent focal shifts. A quote from a former director of Central Intelligence: "The KH-9 has done more for the stability of the world than all the diplomats of the last half-century combined." End quote. The satellite's film recovery vehicles were equipped with a salt plug that would dissolve and sink the canister if it wasn't recovered within a certain time frame to prevent enemy capture. Engineers had to account for solar wind pressure, which could nudge the school bus-sized satellite out of its precise mapping alignment. The agency shared select mapping data with the Department of Agriculture to estimate Soviet crop yields and predict regional stability. The final mission, Mission 1220, was lost when the solid rocket motor on the Titan 34D rocket failed just seconds into flight. Records show the NRO investigated laser blinding countermeasures as early as 1975 to protect HEXAGON from Soviet ground stations. The satellite used a command and control system that allowed ground stations to update the photo target list while the satellite was over the horizon. Audits reveal that the development of the KH-9 required the construction of the world's largest vacuum chamber for testing. The program employed image interpreters who worked 24-hour shifts to analyze the miles of film as soon as they arrived at Hawkeye. HEXAGON satellites monitored the construction of the Soviet carrier Kiev from its first keel plate to its sea trials. The panoramic cameras utilized a slit scan method, exposing the film through a narrow aperture to maintain sharp focus across the wide sweep. NRO records confirm that the satellite's thermal blankets were made of over 20 layers of aluminized mylar to regulate temperature in the sun-drenched orbit. The agency used hexagon imagery to coordinate humanitarian relief routes after a massive 1970 earthquake in Peru. Internal logs show that the KH-9 detected the first signs of the 1973 Yom Kippur War preparations by observing tank movements in the Sinai. The satellite's power was supplied by two massive deployable solar arrays capable of generating over 1,000 watts of electricity. Mission 1201 tested the first film splicer in orbit, allowing the cameras to switch between different film types mid-flight. Blueprints show the SRV capsules were designed with an ablative heat shield that burned away to protect the precious film during the 3,000-degree re-entry. While the camera specs are largely declassified, the deepest shadows in the Hexagon archive are found in the reports regarding Mission 1201 Recovery Anomaly. This section features the heaviest redactions in the entire NRO collection, with over 150 pages of technical data completely scrubbed. This is where the black ink tells a story all its own. Something fishy is going on beneath the waves of the Pacific. While the official record says the film was the only goal, many look at the heavy redactions and see a different prize. A wild theory suggests that during a failed capsule recovery, the agency didn't just find their own film. They believe the SRV landed directly on top of a sunken Soviet spy buoy. The redactions might be hiding a chance infiltration, where the agency used the recovery of hexagon film as a cover to dredge up top-secret Soviet naval encryption hardware from the seabed, literally fishing for secrets. The silence of space might have been a lot louder than we've been told. Beyond the declassified mechanical failures, there's a buzz about co-orbital interceptors. Some believe the redactions hide evidence that Soviet killer satellites actually attempted to blind the hexagon cameras with ground-based lasers or kinetic strikes. This conspiracy posits that the blacked-out pages contain the logs of electronic warfare in orbit, proving that the Cold War actually turned hot in the silence of space hidden by the NRO's sensors. Perhaps the most extreme legend involves the northern latitude surveys. Because the mapping was so thorough, rumors have swirled that the redactions hide photographs of an unidentified non-Soviet installation found in the high Arctic. Some go as far as to suggest the agency discovered an ancient or extraterrestrial structure through Hexagon's mapping cameras, and the redactions are the final wall protecting a discovery that would rewrite the history books. A bizarre theory circulating in dark corners of the web concerns Frame Skip 12. It's rumored that Mission 1212 captured images of Soviet air bases where the planes appeared to be in two places at once. The conspiracy suggests the redactions hide evidence of Soviet experiments with localized time dilation or cloaking fields that were only visible from the specific ultraviolet spectrum used by Hexagon's lenses. Was Hexagon a success? Tactically, it was an optical triumph. It successfully provided the highest resolution wide area imagery ever seen, allowing analysts to count the rivets on a Soviet tank from orbit. Strategically, it was a geopolitical anchor. The project was a success in that it allowed for the verification of the SALT and START treaties. Without Hexagon, the U.S. would never have felt safe enough to sign arms reduction agreements. The success of Hexagon is found in the fact that it prevented a nuclear war by removing the fear of the unknown. It successfully exposed the missile gap as a myth, showing that Soviet capabilities were far lower than previously feared. The agency successfully turned the entire planet into a glass house, a move that stabilized the Cold War for 15 years. It was a categorical success in mechanical engineering, with the complex film path functioning perfectly in temperatures ranging from freezing to boiling. By utilizing Hexagon, the CIA successfully proved that no secret was safe from the high ground. However, the project's success was also its financial burden. The reality that it required a massive infrastructure of ships, planes, and rockets to keep the information flowing. It successfully proved that visual intelligence is the ultimate arbitrator of truth in international relations. The mission was a total success in mapping every inch of the Soviet military-industrial complex. It successfully established the United States as the undisputed master of orbital reconnaissance. Ultimately, it was a success because it replaced speculation with hard fact. It successfully transitioned the agency into the era of technical intelligence, proving that a camera could be more powerful than 1,000 spies on the ground. It was an unparalleled success in the history of aerial photography, providing a level of detail that would not be matched by digital systems for years. The program was a crowning success for the Perkin-Elmer Corporation, setting a standard for space-based optics that still exists today. It was a strategic success that forced the Soviet Union into a position of transparency they never wanted but could not prevent. As far as technological and operational breakthroughs go, the orbital architect resulted in breakthroughs that define modern spaceflight and imaging, such as large-scale precision optics. The massive lightweight mirrors developed for HEXAGON are the direct technological ancestors of the Hubble Space Telescope and the James Webb Space Telescope. Autonomous re-entry and recovery. The heat shield and parachute systems used for the film capsules provided the foundational data for modern spacecraft recovery, including the capsules used by SpaceX and NASA. Ultra-high-resolution film chemistry. The specialized film developed for the KH-9 led to modern medical imaging films and the high-speed photography used in automotive safety testing. And atmospheric compensation algorithms. The math used to deblur images taken through a turbulent atmosphere is now the basis for modern satellite-based GPS mapping and Google Earth clarity. HEXAGON reminds us that peace is often built on the ability to see. The orbital architect proved that the agency could reach out and touch the most hidden corners of the world with nothing but light and film. The film canisters are now empty and the cameras are in museums, but the legacy of global transparency remains the foundation of modern security. We are still living in the world that HEXAGON mapped, a world where the high ground is the most crowded battlefield of all. The silence of the vacuum was broken by the mechanical whir of progress, a sound that meant the era of total secrecy was over. Despair may be a weapon on the ground, but from orbit, the agency found that clarity was the ultimate tool for stability. The architecture of the Cold War was held together by the thin strips of film that fell from the sky. Every digital map you use today is a descendant of the physical film that once plummeted through our atmosphere. We must remember that the eye in the sky sees the shadows, but it also finds the light. In the cold dark of space, we found the perspective we needed to survive the light of day. Clarity isn't just about resolution, it's about the courage to look at the truth without blinking. Space is no longer a silent void, it is a repository of our collective history, captured in 60 miles of silver and shadow. Thanks for listening, stay safe, and remember, the higher you go, the more you see, but the less you can hide. Join us next time as we examine Project Dragon Lady. At the edge of space, a silver ghost continues to haunt the enemies of the state. We'll uncover the facts behind Project Dragon Lady, the designation for the continued evolution of the U-2 platform. It was a game of aerophysics, high-altitude surveillance, and the enduring legacy of invention that refused to die. Join us next time for the Eternal Sentinel. In the meantime, I'll see you in the archives.